In this section, we're going to study the graph of some basic functions. There are 6 of them. But before we get there, we need to study one other property of functions, and we call that continuity. This is an informal definition. You get to the formal one if you take calculus. So it says that a function is continuous over an interval of its domain if its hand-drawn graph over that interval can be sketched without lifting the pencil from the paper. So as long as you can graph the function without having to stop for a reason to go somewhere else or to have a hole, then the function is continuous over that interval. Okay, so let's look at the only example actually we have. Example 1, describe the intervals, so be careful what we are asking for. The intervals of continuity for each function shown below. So for the first one, A, you see that the graph you can draw all the way without lifting the paper from the pencil, so that is continuous everywhere, meaning as an interval it is from negative infinity to infinity. Let's look at B. You'll notice in B that there's a hole. So if you're drawing here, you have to make a hole and continue. So there is a discontinuity at 3. But they did not ask us where is it discontinuous. The question is ask us to find the intervals of continuity. So where is it continuous? It's continuous from negative infinity to 3, but not including 3. And then again, not including 3 to infinity. This is how we explain. We saw that before, where it is all real numbers except one value. So you have an open interval on that value. Let's look at this one. So this one looks like, okay, there is a hole here, and then you're continuing. So the biggest mistake students do here is they say that it's from negative infinity to negative 1 because that's the only number you see. But that is incorrect. How come? Because again, we're looking at the interval in the x values as always. So where is it continuous? From negative infinity to 0, and then from 0 to infinity. So the discontinuity is at 0, not at negative 1. So this is from negative infinity to 0, not including 0, then 0 to infinity. How about this one? You'll see that again, even though this is a 1 here and this is a 3 here, that's the y value. We're not interested in that. We're interested in the x value. But if you see that this is continuous from negative infinity to, again, the x value is 0, but there is a closed interval here, closed at, it's including that point, so it is closed at 0, and then open and 0 to infinity. Okay, so now let's look at these 6 basic functions. We will expect you to memorize these graphs of these 6 functions by heart, and you should know also how to graph them, you know, without a calculator and stuff like that. So let's look at the first one, and I'm going to go through these very fast. You have them. We call the identity function, which is f of x equal to x, meaning y equal to x. All we need here is like 2-3 points, and I will concentrate on only these 3 points. So when x is 0, all of these function, when x is 0, y is 0. So 0, 0 will be in all of these functions. So 0, 0, 1, 1, negative 1, negative 1, then you'll have a line. You got the domain and range, and where is it increasing, and it's continuous. The second one is the squaring function, and that's y equal to x squared. And you will see, again, these are the points we are going to concentrate on. 0, 0 is always there, 1, 1, 2, 4, then negative 1, 1, negative 2, and 4. They are symmetric. You have the domain and range, the increasing. Again, I want you to read it and look at them and memorize how the graph looks like. We have the cubing function, and these are the points we need, 0, 0, 1, 1, 2, 8, and the opposite, negative 1, negative 1, negative 2, negative 8. These are the domain and range, increasing, decreasing. The next one is the square root. Again, you need to memorize all the graphs. The square root meaning y equals square root of x. The points we are gonna look at 0, 0, 1, 1, 4, and 2 only. That's all I will be asking from you to know. That's the property, and the graph looks like that. The cube root function. These are the points 0, 0, 1, 1, 8, and 2, and the opposite, negative 1, negative 1, negative 8, and negative 2. It looks like that. Be careful with the, how they look like. Practice them if you need. The last one is the absolute value function. And the absolute value function, 0, 0, again, all of the points. When x is 1, y is 1. When x is negative, negative 1, y is 1. So these are the 3 points. We don't need more than 3 points because it's linear on both sides. Okay, so now we're going to look at the second part of this section. And here is what we talk about piecewise defined function. What does it mean, piecewise? Meaning we're going to define the function in pieces, piecewise. So if you look at, actually I want to bring it down. If you look at the absolute value function, we can see that we can represent it differently. We can say that f of x equal to the absolute value of x. This function is none other than, so we're going to open this braces. If you look at the right hand side, this looks like the identity function, right? Which is y equal to x. When x is 1, y is 1. X is 2, y is 2. So this function looks exactly like x if x is greater than or equal to 0. Meaning, if you only look at the right hand side. Now if you look at the left hand side, you'll see that you're going to have the opposite. So when x is negative 1, y is the opposite of negative 1, which is 1. So I can represent it as it's equal to the opposite of x if x is negative. So if x is less than 0, like a negative 1, then the function is negative of negative 1, which is positive 1. And this is how piecewise defined functions look like. So we define them in pieces. We can have 2 pieces, we can have 3 pieces, and so forth. I'm going to do the examples here, all of them with you. So let us see the first one. We're assuming again that you already know the basic 6 basic functions. So this function f of x is equal to x squared if x is greater than or equal to 0, x if x is less than 0. So we already know that the graph is going to look something different from here to here than it is from here to here. But also we need to know how to evaluate these functions, how to graph them, how to find domain and range and all that. So each problem in this section, I am going to work all of it with you. First of all, how do we evaluate? What is f of 1? To evaluate these functions, we first look at the x. X is 1. Is 1 greater than or equal to 0 or less than 0? Obviously, it's greater than or equal to 0. So when I want to evaluate this function at 1, I should look at the top part. Okay? because x is greater than or equal to 0. So when x is 1, 1 squared, that's 1. How about f of 2? Where does the 2 belong? Does it belong to the first or the second? Well, 2 is greater than or equal to 0, so it belongs to the first function, and this is x squared, meaning 2 squared or 4. How about negative 2? Negative 2 is less than 0, so we have to evaluate it at this part. This here says that y equal to x. So if x is negative 2, y is negative 2. How about the 0? The 0 actually belongs to the first one, so we have to evaluate it here. 0 squared is 0. Now let us graph. We again assume you know how to graph these functions. So now, for the first one, make sure you only graph the right hand side. So it's the x squared which we just looked at. So 0, 0 is part of the x squared, 1 and 1, 2 and 4. I told you these are the only points we need, but let's go ahead and do 3 and 9 to be accurate. And the graph on this side is going to look like this, and only like this. So do not attempt to do the other side, because we only have x is greater than or equal to 0. Now, if x is less than 0, then my function is the identity function, which is the first one we studied, and that is the a line that is 45 degrees. So I'm going to actually use this to be more accurate. Okay, so it is this line, and only this line. So again, it doesn't go both ways, it only goes one way on one side and the other way. So that is how piecewise defined functions, they're going to look. So this is the nicest one. They're going to look really weird and funny. How about the domain? Well, we see from the graph that the domain is all real numbers, negative infinity to infinity, and the range also, you'll see that it is all real numbers. Increasing, where is the function increasing? Go left to right again. So left to right, we will see that the function is increasing everywhere, meaning from negative infinity to infinity. It's never decreasing, it's never constant. Where is it continuous? Well, it's continuous from negative infinity to infinity. Continuous everywhere. There is no holes or anything. So that's the first one. I'm going to do a few more with you. So let's see the next one. The next one is not a standard basic function, not one of the 6 ones. So we will see in a minute how we graph. F of x is x plus 2 if x is greater than or equal to 0, 2x plus 3 if x is less than 0. So let's evaluate. 1. Where does the 1 belong? And be careful, just because the first 2 had the 0, not all the problems are going to have zeros as the cutoff point. So the 1 belongs to the first one, and to evaluate, you have 1 plus 2, which is 3. How about 2? 2 is also greater than 0, so 2 plus 2 is 4. Negative 2. Negative 2 is less than 0, so we're going to evaluate it here. So 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. And 0 belongs to the first function. So when x is 0, y is 2. You can't have 2 values. Remember, it won't be a function. Now, to graph it. So how are we going to graph this? I'm going to make a table. Okay, so let's see. Maybe I'll make it here. I'm going to call this 1, this 2. So for 1, they're linear functions. So all I need is 3 points. And for 2, also it's a linear function, so all I need is 3 points. For the first one, be careful to give values of x that are greater than or equal to 0. So I'm going to get 0, 1, and 2. These are more than enough points. So when x is 0, y is 2. When x is 1, y is 3. When x is 2, y is 4. Let's graph this. So we have 0, 2, 1 and 3, and 2 and 4, and as you can see, it's a linear function with slope 1. So that is just a line going that way, and it's a dark circle here because that 0 is included. For the second one, I want to do a mistake with you so we can learn from it, but not something we need to erase. So when you're asked to find, to give 3 values and x is less than 0, the first reaction, what is less than 0, is -1. How about another one, which is -2? And I'm going to stop here at these 2 values. So let's see. When x is -1, this is 3 minus 2, which is 1. When x is -2, that is -4 plus 3, which is -1. Let me just put these 2 points to see what's happening. So I have -1 and 1, and then I have -2 and -1. And remember, this is going down where x is less than 0, so my line is gonna go this way, trying to get the slope correctly. The slope is 2. So okay, that's good enough. Okay, so here's what I have so far. Let's look at this. What's wrong with this picture and how can we fix it? Well, if you look at the domain is all real numbers. X is greater than or equal to 0, meaning 0 and positive, and I have values for x is less than 0. But if we look here, we see a gap. So what is the problem here? The problem is when we picked the points and we needed something less than 0, we went to -1. But it turns out to be that you always have to put the cutoff point, which is 0, evaluate it at 0. So when x is 0, then y is 3. Go here and put that point, which is 0, 3. But the only difference is that now this is an open circle. Why? Because it is not equal to the exactly 0. But remember, there are values between -1 and 0. There's -1/2, -1/4. So we will be forgetting them if we don't include the cutoff point. Now the domain, again, you can see we used every single x, so it's all real numbers. How about the range? The range, we used -infinity to, obviously, infinity. Again, nice. Now increasing, this is different. It's cutting off, so be careful, even though it is increasing everywhere, but there are 2 intervals from -infinity to 0, not including 0, and including 0 to infinity. That's how we're going to describe these intervals. So -infinity to 0, but not including 0, then include the 0, go to infinity. It's not decreasing anywhere, it's not constant anywhere. How about continuity? It is continuous, just like it's continuous from -infinity to 0, not including 0. That's this interval. Then on this side, the right side, include the 0 and go to infinity. All right, let's keep on going. I'm not leaving anyone for you to do on your own. You have your homework, so let's do this one. Just do it faster a little bit. This cutoff point is a 2, so keep an eye on this. And the first one is less than or equal, and the second one is greater. So you make sure you read this, not assume anything. So let's look at f of 4. Where does the 4 belong? Is 4 less than or equal to 2 or greater than 2? Well, obviously it's greater than 2, so we're going to evaluate this at this side of this function. So 4 plus 1 is 5. 2, where does the 2 belong? First or second? That's the equal part, so it belongs to the first. So to evaluate this at 2, negative 2 times 2 is negative 4. 5 minus 4 is 1. F of 3, 3 is greater than 2, so we're going to evaluate it here. 0, 0 is less than or equal to 2, so we're going to evaluate it there. Now to graph, remember, so let's do this again together. I'm going to call this 1 and 2. And we're going to give points. So for the first one, we need points that are less than or equal to 2. 2 is included. So 2, less than, 1, and 0. These are less than. So let's evaluate at 2. We already did though, but that's okay. That's 1. At 1, 5 minus 2, that's 3. And at 0, it's 5. Now for the second one, even though the 2 is not included, remember I said evaluate at that point, just put a hole. So let's evaluate it at 2, 3, and 4. These are 3 points greater than 2, but we're including the 2, so you're adding 1, so this is 3, 4, and 5. So let's graph. For the first one, I have 2 and 1, 1 and 3, 0 and 5, and the graph, remember, is less than or equal to 2, so it's going to the left. Don't make a mistake and go down here. It's only greater than, less than. Don't go greater than. Okay, and it includes that point. Now for the other one, let's put these points. 2 and 3, 3 and 4, 4 and 5, and the graph is going greater than 2, so we are going to go to the right and only to the right. But the only difference is we are going to put a hole on this value because it's not included. So let's continue. Domain is negative infinity to infinity. The range is, let's look at the range. Remember, it's down to up. So where do we start? We start at 1 and including 1. Then we're going to go to infinity. Where is the function increasing? Let's see, going down here, then it's going up. So it's increasing from 2, but not including 2, to infinity. It is decreasing from negative infinity to 2, including 2. Okay, it's not constant anywhere. Where is it continuous? Oh well, let's see. So it's continuous from negative infinity to 2, including 2, and not including 2 to infinity. Take your time, I hope, and look at, let's see, almost the last one. This is a big thing here to know these piecewise defined functions. This one is 3 intervals, guys, so this is going to look really funky. We'll see it in a minute. So the function is 2x if x is less than negative 2. It's equal to x squared if it is between negative 2 and 1. And it's 4 minus x if x is greater than 1. So let's look at this one. Okay. So first, let's evaluate at 1. Evaluating it at 1. I might change some of these. It's okay. So where is the function equal to 1? There's the equal sign. So I'm going to have to evaluate the 1 on here. So it's 4 minus 1, which is 3. Then I need to evaluate this function at negative 2. So I'm going to change that. And this one I want it to be at 0. Okay, so I'm making some changes now. And this one is, okay, let me do this. I'm not gonna stop the taping. And wait, make this a negative 3. Okay, so these are good values. So we evaluated it exactly at 1. Now, what is f of 0? Where does the 0 belong? So if you look, the 0 is between negative 2 and 1. So I'm going to evaluate the 0 here. And 0 squared is 0. How about negative 2? Where does the negative 2 belong? Is it the first or the second? It's the second. That's where the equal sign is. So I'm going to evaluate it at x squared. So negative 2 squared is 4. Negative 3. Negative 3 is less than negative 2. So I'm going to evaluate it here. So 2 times negative 3 is negative 6. Now the graph, guys. Okay. 1, 2, and 3. So I'm going to put them here. 1. Let's get 3. Because it's linear, 3 points. Less than negative 2, but remember, include the negative 2. Negative 3 and negative 4. So when x is negative 2, multiply your times, that's negative 4. Everything is multiplied by 2, negative 6 and negative 8. For the second one, we already know the points for x squared. But remember, we need it between negative 2 and 1. So how about negative 2, negative 1, 0, and 1? X squared, remember, so this is 4, 1, 0, 1. And then the third one, also it's a linear. Greater than or equal to 1. So a good points are 1, 2, and 3. And it's 4 minus 1, 3. 4 minus 2, 2. 4 minus 3 is 1. Let's graph. So the first one is negative 2, negative 4, negative 3, negative 6, negative 4, and negative 8. And the line is going down because it's less than negative 2. So is the 2 included? Negative 2 included? No, so don't forget to make it a whole. Now let's do the x squared. Negative 2, negative 4, negative 1 and 1, 0, 0, 1 and 1. So it's a parabola, but not a full parabola. Be careful where you start and stop. But the negative 2 is the included, so that's the dark circle, and the 1 is the not included, so you have to put a hole. And finally, the last one, 1 and 3, 2 and 2, 3 and 1, and we're gonna keep continuing down as x gets bigger than 1, including this point, and there's an arrow. Look how funky this graph looks like. But it's still a function. There's only one value for each y. Okay, so keep an eye on all this. Let's look at the domain. Same thing. The domain is, doesn't matter where we stopped. The domain is what x values did we use? Well, we used every single x value, and you can tell from here. So that domain is all real numbers. How about the range? Let's look at the range. Remember, we're going down to up. So let's see. Starting at negative infinity. Remember, this is also negative infinity. I used every y. I'm still using every y here. Still using every y. All the way until the last point we use is 4. So the range is negative infinity to 4. And it's a dark circle, so including 4. Now, oh, we need the graph. Keep it. Increasing. Let's see. Okay, that's going up. So we have, first of all, we have from negative infinity to, remember the x value, to negative 2, not including negative 2. And if you keep, now we see that it's going down, but then again we see it going up from 0 to 1, but it is including The 0, no, actually it's not including the 0 because it's in the middle. We don't include points that are in the middle of the graph. So it's from 0 to 1. Decreasing, we'll see that it is decreasing from -2 to 0, but it includes the -2. And also decreasing is from 1 including the 1 to infinity. It's never constant. The continuity is a big one. Let's see the interval where the function is continuous. Well, the first one is from -infinity to -2, not including -2. Then include -2 to 1, but don't include the 1. Then include the 1 and go to infinity. Hopefully this all making sense. You can watch the video as many times as you want. This is a nice last example. It just say give a rule, so give a value of f of x. We can see there's 2 intervals and the cutoff point is x. So how about if I say here, if x is greater than but not equal, so only greater than 0, is different rule than if x is less than or equal, because that's the dark. Well, first of all, that's a constant function. That's -4, so that's an easy. So y equal to -4 when x is less than or equal to 0. But what is the equation of this line? We already covered the equations of line. So we know that the y-intercept is 3 and the slope is 1 because it's 1/1. So how do we write the equation of a line with a slope 1 and y-intercept 3? X plus 3. Okay.